Let's get started.
Great. Hi, Joe.
Hi, David. Maybe you want to introduce yourself a bit to the audience.
Sure. My name is David Anderson. I've been teaching the world about Apache Flink for the last 5 years. How about you, Joe?
My name is Joe, and I'm heading engineering at Bavarica. So yeah, I got this interesting problem. Let me share my screen with you. So my boss provided this Kafka stream to me. It's essentially account numbers with bytes used in a mobile network, and they want to gather an overview over all the data usage within the network. And he also wants to alert the accounts when they reach a specific quota, so that they're aware that at one point, the mobile data will stop operating.
Yeah, this looks like a classic streaming use case. Should be a good fit for Apache Flink, I think.
Yeah, so we did some research. We created a great board for that, the Trello board. And so the requirements that we have is essentially that we want to provide an overview to the management, what is happening within the network. But we also need to make sure that we alert the users whenever they get close to their quota. So there should be an overview about the monthly usage for the management, and the user should be alerted. All actions should happen in real time for sure. So we don't want to send them the information that the quota is reached like a couple of days after it actually happens. There are also some functional requirements. We want this to be highly available, and we want it to be fault tolerance. It should be easy to scale. So we're about to grow the network massively. And we also want to deploy that in customer data centers all around the world. And they are like in all clouds, and they have on-prem setups. So we should be quite open to that.
Well, those requirements are well aligned with what Flink can do, as I think you know. There's a couple of interesting things about this application, though, because it combines both analytics and something event-driven where we have to send these alerts. So we'll have to see how we can satisfy both of those requirements.
Yeah, so we did some research. We looked into some interesting projects, and one of that was Apache Flink. This overview looks like exactly what we need. So maybe you can, in a couple of words, mention what's going on here.
Well, I think that the top level takeaway here is that Flink is a stream processor, and the data that Flink is going to process has to come from somewhere and end up going somewhere. So that's what you're seeing in this diagram is data coming from things like databases, file systems, event logs, passing through Flink, and then going somewhere in the end.
Yeah, sounds perfect. And also the description that we found with unbounded and bounded streams, all common cluster environments, close to in-memory speed at any scale, that sounds fantastic. Also, the architecture sounds really, really interesting to us.
Yeah, that's right. So Flink has, as you know, a bunch of interesting features. Part of what makes Flink tick is really the way that Flink supports state. So the state is always local to the nodes that are processing it, but it's being occasionally snapshotted to somewhere durable like S3 or HDFS, some distributed file system. So that way we can have Flink operating quickly on your data because it's in memory and local, but we know that it's then securely snapshotted somewhere in case something fails and we have to recover.
Nice. But we also know that we need to build applications on top of that. And we found the all the things, all the application layers that Flink offers quite appealing. So for sure, working with streams, time management is a big concern. So Flink provides like events time, processing time, watermarks, lateness, windowing, but also has a lot of interesting APIs to access all that. So there's even the possibility to use SQL to write the jobs.
That's right. And that all sounds like it might be a bit complicated, but I think as we start looking at how to satisfy your use case, we'll see it's not that hard.
Yeah, so what's also interesting are the use cases. So we see event-driven applications where it's like fraud detection, data analytics applications where it's about quality monitoring of telco networks, for example, and data pipeline applications where it's about real-time search index building. So that sounds like a great fit for use cases like we have at hand. So how do I get started with Flink?
Well, one good way to get started is just to go ahead and download Flink and install it.
Yeah, that's exactly what I did on my second step here. So I just curled for it and then extracted it. And then you can see, for example, what Flink offers in the binary folder. And so there is a lot of things to look into that. And but the most important comment is for sure starting a cluster. And this comment sets up a standalone session cluster. And the good thing about this package is that there are also some examples. So we can run this example, and then we can have a look at what happened in there. So, for example, produces this output. Flink
that looks like a classic word count example, right?
It is, yeah. So that's for sure not the most sophisticated streaming or batch use case, but it's something we got a job running on Flink, and that's a great thing.
So, part of what's nice about the Flink setup, I think, is that the out-of-the-box experience just works. There's no configuration required. You can just download it and start running without changing anything.
Yeah, and so what also comes with Flink is this dashboard. So you can have an overview over running jobs. For example, we have here this streaming word count example that is already finished. You could inspect what was happening in there, but we will have maybe a little bit of a deeper look into the dashboard at a later point. So we're gonna go back to our tasks here. So we installed Flink, we submitted already our first job, and we inspected the web UI. But maybe, David, you can tell me a little bit of what happened in the background there.
Right. So the cluster that you started up had a job manager and a task manager. So what are those pieces? Well, when you actually ran your word count program, that's what you see on the left there, this Flink client program. And what's happening when you run a Flink application is it's building up the data flow graph that represents the computation to happen later in the cluster. And that graph is submitted along with the code to execute it to the job manager. The job manager plays this overall coordinating role for the whole cluster, and it's responsible for hosting the REST endpoint that people talk to control the cluster, and it's responsible for obtaining resources to run jobs and monitoring that those resources are continuing to run. And it's the task managers that are actually doing all the heavy lifting. That's where the jobs are actually executing. So the task managers are the workers in this setup.
Cool. So I think there's one thing left to do on this example, also to be ready for further examples, and that's essentially stopping the cluster. That's what we're going to do now. And then we can also have a look at how when you develop something, you at one point might need to touch code unless you go for SQL only. But then you might want to bootstrap a project. And when you dig into that, there's this handy command that you can just curl this bash command and pipe it in there. We want to do that for version 1.13. That's the one that has been just released. And this will set up a Maven-based project for you that you can start coding right away. You did that already for me, David. So you
Indeed, I did.
You came up with some examples. And so let's have a look at what...
Yeah, it seemed like your first requirement was to get an overview of all of the users in the network and how much data they were consuming. So that's what this job does here. So you can see at the beginning, we're just setting up the Kafka topic, figuring out where Kafka lives. We're setting up the Flink environment. One of the first things you do in any Flink job is get a hold of the stream execution environment. You'll notice here that in this particular case, we're going to try this first in batch mode. So this means we'll consume all of the inputs and run it to completion and produce a final result. That's what batch mode means. And you can see as we scroll down a little bit here, what I'm doing is setting up the Kafka source. Your data is in Kafka, it's in a particular topic and so on. And you can see here, I'm setting the starting offsets. I've picked October 1st as when to start, and I'm going to consume up through the end of October. So that's what that set bounded is doing, is just setting the range of offsets in Kafka to consume. And then if we look down at what's actually going to happen in the job, it's going to read in that data and compute some simple analytics on it. So it's going to group by account and select the account and the sum of bytes they used.
And then at the end, we're going to print the results. I already started the job in the background. And yeah, so we can see here the account ID with the data that has been consumed.
Yep. And the date shown is like the last date on which they did anything during the month. Yep.
So the next example ties perfectly well into that. I'm also going to start that you can inspect the result later on. And as you can see here, it's like almost the same as the batch job that we've been running before. There's one difference in the environment. So we are setting the runtime execution mode to streaming. And then there's also difference in how we build up the Kafka source, because we don't set any bounds for the data. Everything else is about the same. And at the end, we're also going to print the results. So when we have a look at that, you can see that this is a constant stream of data being produced by the streaming job.
Yeah, that's really the only difference here, is instead of getting a final report of the total sum used, we're just getting this continuously updating result.
I think next we're going to have a look at the quota enrichment job.
Right. So here I was thinking more about your requirements that we need to keep track of each account's total usage and compare that to their quota so that we can eventually produce some sort of alert as they get too close to their quota. But to do that, first we have to figure out how to get access to this quota information and join it with these streaming usage records. So in this case, I decided the easiest, nicest way to do this in Flink is to use Flink SQL to do a join. Flink SQL has lots of interesting support for streaming joins, and we can take advantage of that here. So the first table that we're joining is based on that stream you have coming from Kafka. So here you can see it's the same data, it's the account, the bytes used, and so on, along with then there's connection information there as part of this table describing how to connect to Kafka. It's very similar to what we saw in the previous example. It's just in SQL instead of in Java code. And then the other table that we're going to use is this stream of account information. Here I just mocked this up. So I just wrote a simple generator that's generating some account information so that we could see how this would work. So that's just another source. And then if you scroll down a little, you can see I'm taking that source and making it work as a table. So I'm just describing the schema that this data has. So for each account, I've got the quota as of a particular point in time. I want to have the notion that users can increase or decrease their quota. So that's why it's modeled that way. And I'm taking that stream of information about these accounts and turning that into a table so that we can use it in SQL. And then here is the kind of the end product of that effort, is joining these two streams or two tables together. And if you look there at the line where it says, from usage join account, that's really where the magic is happening, where it says for system time as of usage.ts. So what that means is each time we get a record from the mobile network about a user having consumed some data, we're checking to see what their quota is right then and using that in our enrichment results. So yeah, we look now at what this is producing when we run it. We should see these enriched usage records.
So it's already running?
Right. So here what you're seeing is the leftmost column there is the account, and then it's some number of bytes used. This is just one of those usage records. And then you can see the quota that user had at that particular timestamp that's in the right-hand column. So this is everything we need now to be able to produce our alerts. We're going to have to add up all these usage records and compare them to the quotas somehow. That'll be the final step.
Fantastic. So we're going to stop that job and have a look at the last implementation of a job. And that's the alerting process function.
Exactly. Okay.
Good. So
right. So in this case, we're using SQL for what it does well is to do this relational join between these two streams to get us the data in the shape that we want for further processing. So the first parts of this example are the same as what we just looked at. We're setting up the stream or table of usage records, telling us about people using the network. Then we're setting up the information about accounts and their quotas in the other table. This is the same as what we just saw. And then we're going to do that join. But here the join is, I've kind of extended the join a little bit to have more information in it. So I've added a couple more columns. I've added the billing year and billing month here so that I can group on those because we're going to want to do some aggregation on a month-by-month basis. So I wanted that to be easy. And then I'm doing something rather magical here where I'm taking that enrichment that we just did in SQL and changing that into a data stream so that we can now process it further using Flink's lower level DataStream API. So you can see I'm taking this stream of enriched records and sticking it into POJOs that are called enriched usage records. So this is how I'm bridging the gap between SQL and continuing on in Java. So now I have a data stream of enriched usage records. And here, this little bit of code is doing kind of setting up everything we need. Key by is the same kind of operation as group by. I'm just partitioning this stream of records by account and by billing cycle so that for each account and each billing cycle, I have a separate partition of the data to work in. And then over each of these partitions, I'm applying this usage reporting function. And if we scroll down a little, we can see what this is doing. It's basically adding up each usage record to compute the sum of the usage and comparing that with the quota that's also in the record. And decided to generate these alerts whenever a user gets to 90% of their quota. That's when I'll let them know that they need to be careful.
It sounds like you're almost there of what we wanted to achieve.
Yeah, I think so. So here you can see, in fact, that's what's happening. We're getting these warnings as people reach the point where they're at 90% of their quota. In this case, everyone's quota is 10 gigabytes. And there you can see what's happening.
Good. So that have been the code implementation.
So why don't we take a look now why don't we go take a look at the dashboard for the Flink cluster that's running this job, so we can get a sense of what's going on in there. Yeah, there you go. Right, so if you click on the job name there, so here you can see a whole job here. So at on the left side, those are our sources. So on the bottom, that's the source for the usage records. Above it is the source for the account update records. You can see that both of those streams are coming together in the middle. That's our temporal join that's producing the join. And then that's coming out and going through our process function that does the alerting. So those are the four pieces of our job. And if you scroll down a little bit, you can see some nice metrics about what's been happening. So you can see how much data has been flowing through this cluster while we've been talking. We've processed hundreds of megabytes of data. Pretty cool, huh?
Fantastic. And that all within almost 30 minutes. Great job, David. Okay, so and now we implemented everything that we wanted to have, but now we also want to have a look at how we could achieve that with SQL only using the SQL client. So I have to spin up a Flink cluster again, but before that, I need to stop this job running here. So this is starting now the same cluster that I downloaded before. And then there's also another handy tool packaged with Flink. That's the SQL client. And when starting that, it's connecting to that session cluster. And then we can create tables and run queries there. A SQL client. I'm doing that now. So that's essentially client where you can run SQL commands like show tables. We have no tables defined yet. We prepared this query here. So that's about the same that you saw before in the code. We are creating the usage table with a count column, bytes used, timestamp. And we're doing that by using the Kafka connector for the topic input. So let's do that. Seem to have worked fairly fine. And we also got a second query, which is doing some computation, some based on the timestamp for every day. I'm going to run that. What's happening in the background now, David?
Right. So what's going to happen is this is going to be compiled into a SQL job that's submitted to that cluster you started up. So, and then what you're seeing here is the total usage across the whole network, across all the accounts, day by day. So this is a simple report for the big boss. So we can just see day by day how much the whole team is using on the network.
And all that in real time based on streaming data. Fantastic. Thanks so much, David. So I think we're fine to wrap that up. So I'm gonna quit that job now. And yeah, why is Apache Flink a good idea for use cases like that?
Well, I think we've seen that it makes it easy. You can to switch between batch and streaming, which is something that many folks are interested in doing. There's a lot of support for handling state in Flink. barely scratched the surface there, but we have really robust state management and also powerful tools for working in time. Everything we showed today was taking advantage of event time processing, where we're operating in the logical time frame of when the events happened, which is really nice for getting consistent analytics.
And the great thing about Apache Flink is, so if you look at the tracks of Flink Forward, that this is all proven by the industry. So you can find a lot of talks, even in those 2 days, but also in the internet about how people using Apache Flink, and they actually do what we're talking about today. Yeah, so if you want to go further, you can have a look at the Flink website, dig into the docs. You can also have a look at the project. There is also a playground that we offer to just dig a little bit into that. And for sure, you can also follow Apache Flink on Twitter. If you want to get a little bit closer to the speakers, you can either follow David or me on Twitter, or you can get trained by David, or you can get hired by me when you look at the careers page of Verica. Thanks so much, David, for showing all the details about Apache Flink. It was really interesting for me, and we hope the audience enjoyed it.
Thank you, Joe.